Tom, should we kick off here?
Let's go, Tim.
All
You're
right.
on the air.
All right. We're broadcasting live from Silicon Valley here. My name is Tim Cox. I'm on the communications team here at Bruvity. And thank you for taking time out of your day for our webinar. In our last webinar, we focused on how to apply artificial intelligence and machine learning across service organizations in the home appliance sector. In this webinar, we're turning our attention to the commercial food service sector, which means we're going to focus instead on the commercial equipment in restaurant chains, QSRs, and other food service operations. In the case of large restaurant chains, dependability is crucial. Advances in cooking technology can in fact be the underpinning of a key brand differentiator. In other words, this equipment is very important. But along with that, uptime, consistency, and quality are extremely important. So in this environment, fast diagnosis and repairs are essential. You have mission critical equipment such as coolers, freezers, and truck fryers, and when they break down, you're going to lose efficiency and you're going to miss key customer service interactions. And the associated costs here can be emergency repairs, wasted inventory, labor costs, and of course, lost business. And today, especially, food service operators are operating in a particularly challenging environment that stresses social distancing and other safety measures. So today, we're going to ask the question, how can technology help? Recent advances in AI and machine learning, coupled with remote monitoring of connected devices, can reduce equipment outages and minimize downtime, enabling food service operators to consistently deliver quality product at a competitive price while minimizing total cost of ownership of the equipment. In today's webinar, we'll be covering the basics of artificial intelligence, which we're going to refer to as AI quite a lot, and machine learning, which you may hear referred to as ML. We'll define some of those core concepts, describe how a machine learning model is built and trained, and then show how these technologies are applied in real-life commercial kitchen scenarios. We'll also highlight some of the Bruvity solutions for commercial food service operators, including solutions that are optimized for remote service triage, AI-assisted fault diagnosis, and parts prediction. So before we start, please note that the chat channel is open for your questions throughout. So feel free to shoot in questions as we go. We will respond to those questions during the Q&A at the end of the webinar. Now let me just introduce a couple of people here. Two speakers will be taking over from me, two gentlemen who represent both sides of the equation. On the one hand, the business side, and on the other hand, the technical side. Tom Meehan works closely with Bruvity's home appliance OEMs, as well as our home warranty and extended warranty customers, and of course, with our commercial equipment OEMs. AJ Walvalakar, meanwhile, heads up our data science organization. So let's get started here by setting the scene for today's business environment in the commercial food service sector. For that, I'm going to turn things over to Tom. Good morning, Tom.
Good morning, Tim, and thank you so much. Okay, so I'm just going to do kind of a little setup of this from kind of maybe a technology and a business perspective. Okay, and AJ is going to take over and talk a lot more about kind of the ingredients, technology, and methodologies around AI and ML in this environment. And then I'll be back a little later talking about kind of solution and apps that Bruvity has specifically that utilize this AI and ML technology in the models that are built. Okay. So AI and ML technology is continuing to be more widely deployed across many industries, and now by a lot of companies in their service environment. And Bruvity is the market leader in providing AI ML tools for service for commercial kitchen appliances. It's one of our key verticals that we focus on from a business perspective, and we're delivering great solutions in that field to our either OEM customers or servicer customers. But only one thing, it's been kind of it's been a really tough year for restaurants, for commercial kitchen appliance OEMs, and for the companies that provide service for them. Okay. However, at the same time, we've seen a lot of innovations in the industry, with QSRs, with greater efficiency in the food delivery area, with the emergence of solutions like ghost kitchens that are really optimized around a non-physical restaurant that's virtual and that provides delivery capabilities to multiple restaurants within the same physical infrastructure. Similarly, in the equipment service and operation area, there's been new solutions coming to the fore from companies like Bruvity that can help OEMs reduce their warranty costs, increase overall first-time fix either in a call center or from the services themselves, improve customer experience, and in the era of COVID, enable call center agents or service technicians to have tools that maybe allow them to fix problems remotely without a technician having to visit and come into the employee area of a restaurant. Okay. We've also developed customer self-service capabilities that are now sort of beginning to be used in this market, with restaurants in some cases looking initially to try and triage and fix the problem themselves. Okay. I'm going to hand over to Ajay and be back a little later. He's going to talk a lot more about kind of the ingredient ML and AI technology and its methodologies. So Ajay, over to you, and I'll be back in a bit.
All right, thanks, Tom. Intelligence, ML, machine learning. These terms have become very popular these days. With the explosion of data and increasing computing power that is available, it has now become possible to use this technology for real life problems. But before we dive into how these technologies can be used in the appliance service industry, let me quickly describe what is AI, what is ML, how are they related to the traditional software programming that we are all used to till now. So artificial intelligence is a wider term encompassing any technology that helps create computers that can reason or do functions automatically. So even a calculator can be seen as an artificial intelligent device with a limited intelligence. Various methods such as logic, rules, decision trees are also part of AI. Machine learning is a subset of overall AI technologies. So what machine learning is a set of computer algorithms that can learn from data without any rules being specified on how to or what to learn. Most of these techniques existed in the domain of statistics for many decades. But like I said, we now have huge amounts of data available and cheap computing power available. So we are able to process this vast amount of data, and we are able to use these techniques in real life now. What has mainly caught on now is a subset of ML algorithms called deep learning algorithms. These deep learning algorithms, such as artificial neural networks, they can learn from huge amounts of data. For example, to train a model to understand English language, the entire corpus of Wikipedia can be used with millions of words in it. We talked about what is machine learning. Then we talked about what is deep learning also. But let's see how machine learning is different from traditional programming. Okay. So in traditional programming, we, the humans or programmers, we provide rules or programs or instructions on how exactly to process some incoming data. After executing these instructions on the incoming data, the program arrives at the output. That's the traditional programming that we are used to. For example, the program can be fed input data of all the incomes and expenses during a year. All the tax rules can also be programmed in to calculate then the tax liability of, say, a company or a person. But here we know the exact tax rules to code in, and that's how the traditional programming has worked thus far. We have to know what the rules are, and then we can program them. Now, if you wanted to write a program to differentiate a picture of a flower from a picture of a fruit, how would we do that? We don't know any rules to program for this. When we learn as children, we are not taught rules to differentiate a flower fruit. We see several examples of flowers and several examples of fruit. And that's how we learn to distinguish a flower from a fruit. A machine learning algorithm does exactly the same thing. A machine learning algorithm is provided a lot of data, a lot of pictures of fruits, and it's told that these are fruits. Then it's also provided a lot of pictures of flowers, and it's told that these are flowers. Just like humans, the machine learning algorithm will figure out the rules or figure out the patterns that are required for calling certain picture of fruit. When we input an unseen picture, the algorithm applies these learned rules, and it comes out with a label that this picture is a fruit or this picture is a flower. That's the fundamental difference. Now that we understand this difference, let's look at the steps that are required to build a machine learning model. So there are 7 steps. Here, data is the essential ingredient of machine learning model. Gathering data that is available is the first step of model building. However, on most occasions, the data will need processing to extract data features that are meaningful for the model. This is a very crucial step in the process. It leads to better performing model. You also need to know what type of features are meaningful. So you need to know the problem that you're solving and what features are meaningful for that. Eventually, it is the quantity and quality of data that decides how good a model we are able to build. Available data is usually split to a reasonably small chunk for model validation. The data preparation step. In the next step, we want to solve the objective of the model, the type and quantity of the data. These are the factors that influence the choice of model in this step, or the choice of algorithm in this step. If the quantity of the data is sufficiently large, a deep learning algorithm such as one of the various neural networks can be chosen. If it's not that huge, then we cannot go with the deep learning models. In the next step, the process data is used to algorithm is chosen in step 3, and in step 4 now we are using both of them. So once the data is used to train an algorithm, that's the training step, and at the end of that, what we get is a model. This training involves tuning of parameters that are available for each of those algorithms. These are adjusted such that the model is fitted to the data that is available. This is somewhat similar to fitting a curve through a set of points and obtaining the equation of the curve, but in a much higher dimensional space. And in a much sort of rhythms that are used to do this. A typical neural network model can have as many as a few million tunable parameters. So once the training is complete, we obtain what is known as a machine learning model. So the algorithm is now converted into a model with its tuned parameters. This model can now be fed input data, and the model will output predictions, or model will output answers that we seek from the model. So now at this step, we do have a model, but we don't know how good this model is going to perform on the data that it has not seen or that it has not been trained on. So in the next step, step 5, we if the model evaluation shows that the model is performing with sufficient performance metric, we can deploy the model in production to obtain predictions. But that rarely happens. So we mostly have to perform the next steps, which are hyperparameter tuning. Here we see that the performance is not that great, and we want to see how to improve it. This may reveal some additional features of data need to be extracted, or some additional cleanup steps on data may be required. After the hyperparameter tuning step, we go back to step 4, train the algorithm, obtain a new model. We typically iterate through these steps 4, 5, and 6 multiple times before we have evaluation metric in satisfactory range. Very rarely we need to go to step 3 and choose a different algorithm. But step 4, 5, 6, we need to iterate a few times at least. Once we have a model that is adequately performing as per our requirement, then we go to the step 7, which is deploying and obtaining predictions from the model. This process of building ML models can be used for data of various types. It can be image data, it can be natural language data, it can be uh, many other types of data. So let's look at some common examples for different machine learning models using variety of such data types. So we could build models using images as input data. These machine learning models can be can recognize the extent of physical damage to an appliance based on a picture of the damaged appliance, or it can decide whether it is worth servicing the appliance or it makes sense to replace it altogether. Lot of picture or image based modeling can be done, or and is done. uh, just like image, the input data can be audio data or speech data. Understanding human speech signal is a different type of a ML problem. uh, an IVR that can respond to consumers calling in can be built to reduce load on human agents. Here, what is needed is not just the understanding of the input audio signal is a human speech, but also the language model that understands what the speech means, what is the problem that the consumer is called about. So in addition to speech recognition, a language model is needed to understand the natural language. So speech model hooked up with a English natural language model will understand the English speech and so on, right? So that's another part of a machine learning model called natural language processing. Now we saw in the speech recognition, the natural language is input in terms of audio signal. The natural language can be input in terms of typed information also, written text. Understanding the intent of a sentence will require more than simply understanding meaning of each word. So it's not just a lookup from a dictionary that is going to give you a natural language processing model, but you need to actually understand the entire sentence and the words in what context they appear in the sentence. We will look at this NLP in more detail in a later slide. Uh, Now, in speech, the audio signal was about speech, but you can have an audio signal that is not a speech signal. That can be used as input data. It can be a noise from an appliance, a refrigerator or a fryer or something like that, that can be used to determine whether the noise is caused by something that is problematic in the appliance, a faulty compressor, a jammed auger, or something like that. Very easily available, at least in the open literature. Um, These models are slightly difficult to build unless you have good amount of data to go with that. In addition to audio signal, video signal can be used as input for ML models. For example, a video recording of installation of an appliance can be analyzed by a machine learning model to check if all the recommended steps have been followed or if some steps were missed. So these kind of analysis can be done. In addition to all these sort of modes of input, we can also have sensor-based input. So data streaming from temperature sensors or pressure sensors or a combination of different sensors can be used to, let's say, predict possible faults before they develop. So a lot of these applications today may sound like they are far off in future, but they are not. If the data is there, the processing capabilities are there, the algorithms are there, and machine learning models can do a fairly accurate job of understanding what the data is saying. So there is enough data available in public domain to build a very useful and usable NLP-based applications that can bring in a lot of efficiency gains for the appliance service industry right off the bat. And in the appliance service domain, one of the main workhorse is NLP model in terms of a machine learning model. It's a NLP technology, natural language processing technology. So in the next slide, we'll quickly take a look at what are different parts of a natural language processing model, NLP model, and how they are used to understand the natural language. So in the appliance service domain, there is a lot of text data that is available in open source, such as appliance use and care manual, frequently asked questions, service bulletins, service manuals, discussions about an appliance in appliance repair forums. So a lot of written text data is available for various appliances, OEMs, customer support organizations. All right. In order to use this data to troubleshoot customer complaints or help servicers with analysis of faults and deciding the exact parts that are needed to fix a complaint, we can use this with a state-of-the-art natural language processing. So natural language processing, at the heart of it is a language model. It is broadly defined, natural language processing is broadly defined as the automatic manipulation of natural language, like speech or text by computers. It is combination of linguistic, computer science, and machine learning. The central piece of NLP is the language model. The language model exploits technology in machine learning that is called transfer learning. So what it means is we want to first have a basic English language model that is not talking about an appliance specific terminology, but just simple English. It understands the construction of the sentences. It's able to identify noun phrases, verb phrases, meaning of most commonly used words. This is all embedded in a basic English language model. This model is then, this model can be built by using a huge corpus such as a Wikipedia with like 2.5 billion words, or open book corpus with 800 million words or something like that. And it captures all the understanding of the language very well, but it lacks the understanding of the language that is specific to appliance service industry. So we then fine tune this model with the corpus that is specifically appliance related, such as manuals, FAQs, etc., that we talked about earlier. This helps the language model learn industry specific terms and usage of common English words in English, the industry context manner. So we have performed this exercise and developed our base appliance language model. We can then use proprietary data to fine tune this further to capture knowledge from a particular organization or a particular appliance type knowledge corpus. So the language model consists of different components, such as a lexical analysis that involves identifying and analyzing the structure of the words. Lexicon of a language means a collection of words and phrases in a language. So lexical analysis is dividing the whole chunk of text into paragraphs, sentences, and words. Then we do the syntactic analysis that involves analysis of words in the sentence for grammar and arranging words in a manner that shows the relationship among the words. What is uh, uh, the verb and other parts of the sentence. Then there is a semantic analysis that consists of deriving meaning from the sentence or sentences using not only words in them, but their interrelationship. Okay. Also using the context in which they appear. Just as in case of human understanding of language, it is not a deterministic process, but a probabilistic one, where multiple meanings of the same sentence can be possible with various probability values attached to various meanings. So that's how the natural language processing engine is built. Now, when you provide an input to this model, the model will understand what the intent of this input sentence is, and it will provide an output which can be an answer, which can be a search from a particular document, which can be a clarifying question if there is a natural language generation engine around it, and things like that. So that's how these natural language processing engines work. The natural language model not only learns from database corpus of manuals, FAQs, etc., but also interacts with the corpus to understand the intent of the input text, and then it will deliver the output that is required. As mentioned earlier, NLP technology forms the core of many of the tools that Bruvity has developed for appliance service industry. So in the next slide, we'll look at what are the machine learning models that we have for the commercial kitchen equipment service. So chatbot for troubleshooting equipment issues. That is sort of the core platform on which our models work. So main focus of the tool that we have developed for this industry is on troubleshooting consumer issues or issues with the appliance. A chatbot can be used either by the customer or the support agent as a core channel through which all the troubleshooting help is provided. The chatbot will provide access to the troubleshooting decision trees or troubleshooting FAQ search or manual search or all different types of assets that it can go through. The chatbot is also a gateway through which access to knowledge corpus is provided via smart search. The context of the conversation is obtained from the chatbot. It is used to search through the corpus using NLP-based smart search engine that we have built. This ensures very highly targeted search within the large document corpus, where not only we fetch the relevant document, but within the document, we extract the exact paragraph that is relevant to the query, and we present that to the user. In addition to aiding troubleshooting of appliance issues, once it is established that a technician's visit is needed to resolve the appliance problem, our tools can predict the exact parts that are needed to be carried by the technician, so they can complete the service. The first time fix rates are high because of that. So these are natural language processing or NLP driven tools that we have. We also have image processing driven tools. So many times it is seen that the customer doesn't know the appliance model or in serial numbers. They are not very accessible right away. They can just see the rating plate at a distance. We have models where the customer can just take a picture, and the model from that image of the rating plate, the model will extract the serial number, the model number of the appliance, and provide it to the agent or process it further. So as we saw in last few slides, this ML technology, machine learning technology, can be used to improve effectiveness of customer support agents, increase use of troubleshooting, and generally improve user experience of the consumer with the appliance customer support. The data can be combination of public data along with support organizations' proprietary data. That is an overview of the ML technology that we use for commercial kitchen equipment service. Back to you, Tom. Are there any questions?
Nothing. Hey, AJ, thanks a lot. That was great.
Thanks, Tom.
Yes. So what I'm going to do is I'm going to talk in a little more detail about the products that leverage and use the ML models, AI, smart search, NLP technology that Ajay was describing. Okay. The slide here shows the applications that make up the Brevity product portfolio for commercial food equipment service. Now, there are products available that can be used across by the entire service ecosystem, by a call center, by a field technician, products that also allow a restaurant to do some initial troubleshooting and tries themselves and possibly resolve problems without making a call or having a service dispatch. The Brevity solution also provides a part prediction module where a call center or a field service technician can predict the parts that are needed for a particular job, ensuring the right parts are loaded on the truck and that we are much more likely to get a fix with a first dispatch. And we get great results in this area using our technology and solution. We have an insight management tool that provides for manager reporting, providing a view of what the overall results and service improvements are, and giving a view of individual agents and technician performance. Okay. The Brevity Agent Assist is used by call center agents. It provides a chatbot that as you was talking about, that has a decision tree that allows an agent to triage problems. Okay. Directly in conjunction with that is a smart search facility that provides contextual information on manuals, videos, facts that are directly associated with the issue that the agent is trying to resolve at the time. Okay, and I have a demo in a few minutes that'll kind of walk you through, some of the typical screens that an agent will see with the Brevity Agent Assist. Okay, and this combination of a chatbot, okay, plus plus contextual smart search that gives access to a whole series of resources that are directly related to the problem that is being resolved. Okay. The call center agent, if a service call or truck roll is deemed necessary, can message the service technician, okay, within the same system with information and direction that's associated with the problem. Okay. Brevity Tech Assist is intended to be used by a field service technician. Okay. It has a chatbot capability that will allow the technician to triage problems either on site or before they get to a site. Okay. It has a similar fast smart search facility that allows the field service technician often on site to quickly access manuals, facts, videos, okay, associated with the problem that they're trying to resolve. Okay. Brevity Tech Assist has a mobile form factor, okay, UI, when it's used in the field, okay, to give a optimal look and feel an organization when it's being used in a mobile device, as it often is by field technicians. Okay. Brevity Customer Assist allows for someone at a restaurant to initially triage or troubleshoot a problem. Okay. Now this, in some ways is in a lot of cases is an emerging use case in the restaurant commercial kitchen equipment space. But certainly in the era of COVID, in the era of more probably advanced computer capable people that may be on site or work at a restaurant, okay, we're finding a lot of uptake in this in terms of it being used before a service technician is dispatched or before a call is made to a call center, okay? And we're seeing very good results with this initially with some of our commercial equipment, kitchen equipment, OEMs who've introduced this sort of capability, okay? So what I'm going to do next is walk you through a demo of Bruvity Agent Assist, okay? And you'll see the screens, the chatbot, the contextual information, and I'll walk you through a flow like that. And then I'll show you a couple of flows as well of a Agent Assist that has a parts prediction module built in, and what that looks like. Now, as an agent begins to launch Bruvity Agent Assist, there are a certain amount of things that they might be sending in information about the particular appliance, from a model type to a serial number to an initial description of the problem. Okay, that starts us off on the decision tree that would be how the path that the agent goes down to try and resolve and triage the problem. Typically, we're integrated with a CRM, okay, and we'll get all this information automatically populated into Bruvity Agent Assistance, okay. So this is what an Agent Assist screen looks like when they're typically used in a call center environment, okay. To the right here is a chatbot, and we'll walk you through this a little bit more, okay, which is basically the decision tree that depending on answers and information and data that the call center agent will go down to try and triage the problem, okay. All around it is directly contextual information from either facts, from manuals, from videos, okay, that's directly associated with the problem as being initially described. And further becomes more contextual as we move down the decision tree and get more information about the problem and its potential resolution. There's also contained up here in the top right some service history associated with the appliance, et cetera, okay, and some visualization of the appliance as well. So in a commercial kitchen equipment environment, the agent will have all of this contextual information about the piece of equipment, the actual problem, and a chatbot to be able to look to resolve the problem. Now here the chatbot is actually based on the initial problem description that was put in. We're actually to further qualify, select how you describe the noisy environment that was associated with this particular appliance. Okay, so it then gives you a possible solution. Okay, in this case, it's about leveling a piece of equipment within the appliance itself. Okay, and we can expand that out to give us more information, okay, and more details about it, okay, or we can look at some other specific information around the appliance, go to something in the facts that's directly associated with this information. That's some fact information there. Manuals itself will take you directly to contextual information, okay, that's around this particular model and this particular problem, okay. And then videos will give, booked from either the OEM or from some stuff that's in the public domain, will give you information about how to directly fix this problem, okay? And then you can actually send it to the field service technician, as you would typically do, I think, in an environment in a restaurant or commercial kitchen equipment space, or you can email it directly to the restaurant, for example, to allow them to troubleshoot it as possible. So here we have within the assistant dashboard, the chatbot over here, okay, that provides for all of the triage information, which the agent will go down the decision tree, okay, and input that. This will also, although we're getting suggested, issues here to qualify the type of noise, et cetera, et cetera. You can also enter free text here, and NLP technology will be able to interpret that and take you, to a resolution and stuff like that. So we've come up with a problem resolution. We provided a bunch of more contextual information from a FAQ or manual or video perspective around this information. We're being asked if we solved the problem. If the answer is yes, then we actually record this as a successful output resolution. There's data that's recorded about the issue, how it was resolved, okay, and that further trains the model as well, okay. So in a commercial kitchen environment call center, okay, the call agent will have a screen that looks very much like this, okay, and this will launch onto this other way again. But also remember that the field service Tech Assist, okay, has very similar capabilities, although sometimes in a different form factor, okay, that allows them to have a chatbot to try to resolve the problem, allows them to have a smart search capability to get to videos, facts, parts of the manual that are directly associated with their problem, okay, and with that, a much greater likelihood of them being able to resolve the problem as well. And in both cases, and I'll show you this, there's a parts prediction module that could be part of the Tech Assist, have a module within Tech Assist or a module within Agent Assist that will be used in conjunction with a particular problem that's being resolved. And you'll see in this example, we'll bring up some parts predictions that is directly associated with the problem that's being described, and it's transitioned down the decision tree. Okay. And here we have a slightly different variant of the Agent Assist screen, okay? Here, a whole bunch of contextual data as well. In this case, there's some connectivity that's provided by the equipment as well, so that provides some additional information and additional status, okay, part of the maps. But as you move into the Agent Assist, okay, you'll see the screen here is augmented with previous screen that you had seen that is, a lot of information about the appliance, facts, manuals, the chatbot itself here that's going down. But in this case, we have a parts prediction module as well, okay, that we see being used an awful lot in the commercial kitchen equipment space, and by a key differentiator and needed technology to improve overall first-time fixes and reduce truck rolls and take down warranty expense. So here, based on the information that was input, okay, within the chatbot and the description of the problem, there's a recommendation of the particular parts that would most likely be needed to resolve this problem, okay, and the likelihood of that part being required. So the call center agent can either include this if it's deemed that there's a truck roll technician, field service technician dispatch that would go along with this. We'll use this information to inform the field service technician about the parts that should be loaded on the truck, okay? For our Tech Assist, there's also a parts prediction capability that can be built into the module as well that will allow the field service technician to potentially do some troubleshooting in advance about the problem, the particular equipment type, and with part prediction be able to better put parts on their truck that are much more likely to be able to resolve the problem with a first visit and be needed, and avoid that second truck roll that may have to be undertaken if you don't have the right parts on the truck. Okay. So I just wanted you to kind of go over, some results, okay, that we've seen from some of our major commercial kitchen equipment OEMs from an overall performance improvement perspective, and with that, cost savings, increased efficiency, better uptime, better customer experience, okay? So using Agent Assist, okay, and using some part prediction capabilities, we've been able to do our increased first-time completes from about with a 77% increase, okay? This is, when a call center agent, or in some cases a tech assist, can resolve a problem, okay, without the need for dispatch, okay, using the triage capabilities that are provided with the chatbot and contextual information about the actual issue that may be used in the resolution of the problem. So a substantial increase in performance from the end customer and the restaurant perspective in being able to resolve that, okay, and as showing down here, a component of the reduced warranty costs that OEMs can take advantage of by using our technology. Okay, so warranty costs and the reduction, is a key factor in the performance of any home kitchen appliance OEM. Okay, so if we can reduce that, okay, using technologies that including the chatbot triage, parts prediction, okay, where we reduce truck rolls, where we avoid truck rolls, okay, we've seen percentage reduction in warranty costs down by about 32% by using these range of technologies from triage to troubleshooting to parts prediction that give first-time fixes, that reduce truck rolls, that get a fix for the first truck roll, that gives this great overall savings from a warranty cost perspective. Okay, self-service capabilities, and I think this is a bit of a emerging technology. Okay, but in the commercial equipment and restaurant space, where we provided this, we've seen good initial adoption of this product for something that typically hadn't been available in the past. We've seen an uptake of usage going from maybe a rudimentary tool that they had before we introduced our chatbot and contextual search capabilities, that we've seen a really large increase in the use of this. Now, in often cases, you're comparing it with kind of maybe very rudimentary capabilities that might have existed before. But the ability for the restaurant employee to be able to triage, troubleshoot some problems themselves, okay, in advance of a call to a service center or a dispatch occurring, is one that's ramping up, and it's really strong, I think, overall from an OEM warranty cost reduction, but also from a customer experience and a restaurant uptime point of view. And in the whole area of parts prediction, the intelligence and ML and AI technology we've used to ensure you have the right parts for the job really brings great savings. And this is from an example for one of our customers that's based on first-time fixes when a dispatch occurs and the right parts are on the truck. Okay, we're greatly reducing repeat truck rolls that were there because of the fact that the right parts may have not been on the truck when the service technician, went to do the job. So I'll kind of come back to you, Tim, and from any questions, any comments that we have on some of the stuff that AJ and I have discussed today.
Let's see now. Yeah, a couple of questions. So one is regarding the specific equipment that we are able to include as part of our service offerings. Can you just quickly review those particular devices, appliances, and equipment, Tom?
Yeah, so I would say that the type of equipment we support, again, we often deal with, vendors who have a lot of different brands in that different categories. But among the models we built, okay, and specific models for particular vendor types include ranges, ovens, fryers, refrigerators, ice makers, dishwashers, not really equipment in the power lighting or point of sale perspective, okay, but the range of products that's there in the cooking and preparation of the food, okay. So I'd say ranges, ovens, fryers, refrigerators, ice makers, and we cover all of these pieces of equipment.
Got it. And then presumably then in addition, since there's, for example, HVAC might be another area.
So we have a separate, vertical we focus on in, the commercial HVAC space. Okay. More recently, that's also come into play in in the kind of restaurant space, and some work we're doing in the supermarket space as well. Okay. I should also mention, so commercial HVACs are often part of the solution that we're offering as well. Okay. I should also mention that, and this has actually become quite common more recently, that, some coffee makers, okay, some premium coffee makers is equipment types that we develop models for, okay, and are getting very good results and solutions in that particular equipment type.
Mm-hmm. Okay, another question is, can we point to any specific improvements that we've delivered, service performance improvements in this commercial equipment sector?
Yeah, so the numbers I was giving you there, from a case study perspective, okay, are from a commercial kitchen equipment OEM, okay, and they've seen great results in overall reduced warranty costs, okay, which is a major expense for them. In this case, I think customer assist and the sort of that capability was sort of new. But we've seen, a big adoption on it, by some of their end customers. Okay. And within the realm of warranty costs, the parts prediction savings that, the savings that are delivered from a parts prediction perspective, have really been pronounced in terms of reduced truck rolls, one truck roll rather than having to do any of the 3 truck rolls because you don't have the right parts for the job. Really great results in performance and cost savings that are coming from that.
I think we've got time for one last question here, and that is regarding the areas that we have specific relevance. Here we are, COVID, coronavirus, and restaurants, food service having to manage their way through that. Yep. And are there specific areas or segments of the commercial kitchen food service sectors where we can really help people with regard to COVID?
Yeah, well, I think there's a couple of factors. I think, we've seen, particularly in the kind of QSR area, okay, they have, in the COVID area, they've had sort of new requirements around kind of efficiency and uptime, okay? So the triage capabilities that we have are being, able to help. We've had a certain degree of focus on some equipment types that are used by that restaurant type category in the QSR, okay? So there's one element that, just better triage, better parts prediction, it leads to better uptime and quicker fixes, okay? But we inherently also have some capability that allows for remote fixing, okay? So, whether it's the agent or the tech that's able to resolve a problem using our tools without having to go in, on site, without having to do a service dispatch, without having to go into, say, the employee restaurant of the area, this is really kind of COVID friendly and being able to do remote fixes, okay? And the customer assist tools we have now allow restaurants or, to be able to try and resolve problems themselves, without actually making a call, and obviously with that, without, having to dispatch a service station. So in the area of, I'd say from a COVID point of view is, definitely kind of a QSR focus for us and the equipment they use and optimizing their uptime and their service delivery. But the ability to remote fixes by our advanced triage capabilities or to have the customer assist capability be used, reduces the overall need or requirement for on-site visits, and with that, a much more safer service operating environment with COVID.
Right. Okay, thank you. Well, we're coming up to the top of the hour. I think we're going to draw things to a close here. So thank you, Tom. Thank you, AJ, for today's webinar.
Thank you, AJ. Thank you, Tim. There will be a recording of this available. If we do get some additional questions after the event, okay, we'll look to respond to those as well. Okay.
Yeah, and also we'll be updating on the blog, I imagine. Any other questions? So that's always a good place to drop by and see what's been going on at Brividi. Okay, thank you, everybody.
Thank you, Tim.
Thank you. Bye-bye.
Thank you, Adi. And thank you, our attendees.